So yesterday when we were factoring and going through our little checklists, we were factoring to find a binomial pair of factors. And when we were factoring to find a binomial pair of factors, our C value, our constant, was always positive. And that's the case that we had yesterday. Incidentally, quadratic expressions in expanded form can be expressed as x squared plus bx plus c. You'll notice that we are missing a letter in the alphabet here. Any ideas what that is? A. So the next step is to have an A term here, which makes factoring more complicated. But that's not what we're talking about today. We're talking about when the squared term or the quadratic term has a constant of 1. And today, our constant C is going to be negative, which means there's going to be a little more work involved in doing these, but the process of factoring is going to be the same. So here we go. Let's take a look at this problem right here. We have x squared minus x minus 30. What is the first thing you look for when you factor? What is the first thing that you do when you factor? It's not going to change from yesterday. Trevor? No, that is not the first thing. We do not look for the factors of 30. The first thing that we are going to do, Brittany?
Find the greatest common binomial.
We're going to look for a greatest common monomial. So the whole checklist idea does not go away. So the first thing we look for, again, is the greatest common monomial. Is there something that goes into all three of these terms?
No.
No, so we don't have it. So what's the next thing that we look for? What is the next thing that we look for? We're on to the boys, girls. Ava?
Difference of squares.
We look for a difference of squares. So what do we look for in a difference of squares? How would we know if we're looking at a difference of squares? What must be true if this thing here is a difference of squares? All right, Joe? It has to be a binomial with two square numbers. Not always a binomial, but yes, more or less. It needs to be a binomial with two square factors. And what is the last piece? Think difference of squares. Betsy? It needs to be subtraction. So this one satisfies the whole subtraction bit, because that's all we've got there. But is it a binomial? No. Is negative 30 a square?
No.
No. And incidentally, you will never have, if it's a negative c term, it can't be a square, because something times itself will always be positive. So the third thing that we look for is, Ethan? A square binomial. And we've just proven that negative 30 is not a square, partly because it's negative and partly because 30 just ain't a square number. So we know we don't have a square binomial, so the fourth thing we look for is a binomial pair of factors. Okay, so we're down to the table or the rectangles. I don't care which one we use. Which would you like to use?
Table.
Table. We'll use the table first. So what are the headings for the table? What are the headings, Ethan?
Factor.
Yeah, we're going to have a factor, sum table, factor and sums. We're looking for factors of what number? Excuse me? Negative 30, and we have to include that negative. We're looking for a sum of, not x, not 1, negative 1. Because in front of that x, there's a number that we don't have to write. It would be a 1. All right, so let's come up with some factors for negative 30. How do you get a negative product? What must be true about the two factors to get a negative product? Olivia?
One of them must be positive and one of them must be negative.
Excellent. One must be positive, one must be negative. All right, so let's come up with some factors for negative 30. Brandon.
Negative 15 and 2.
Negative 15 and positive 2.
Negative 6 and 5.
Negative 6 and 5.
Negative 10 and 3.
Negative 10 and 3.
Negative 1 and 30.
Negative 1 and 30. Can anyone think of any other factors? Factor pairs, I should say. Peter.
5 or negative 5 and 6.
Okay. Yes, sir?
Negative 2 and 15.
So you notice you will have to reverse them because negative 5 and 6 is different than negative 6 and 5. So here you do have to look at the reversals, or the opposites. So then the other ones, well, let's just get started with this. Let's see what our sums are. Let's see if we come up with the sum of positive or negative 1. So what is the sum of negative 15 plus 2? Jenna? Negative 13. Nope. Doesn't satisfy our condition. What is the sum of negative 6 and 5? Negative 1. All right, we have a wiener. So what is the equivalent expression in factored form? What is the equivalent expression in factored form? Betsy.
X minus 6 times x plus 5.
X minus 6 times x plus 5. And I don't particularly care which binomial comes first. Yes?
So that checklist, none of it works when you go on to that bucket.
Yeah, so that's the first. So greatest common monomial is what you look for first. Difference of squares is what you look for second. Square binomial third. And then looking for a binomial pair of factors. And we'll be adding to this list just a little bit more. And then you have to keep going through that. The trick is, if you end up with a squared term inside one of your binomials, then you're going to have to go back and look for a difference of squares, because you may have to factor multiple times. And if you factor out a greatest common monomial and you still end up with a squared term, you may still have to factor again. So you can, it is all saved for posterity's sake, sir. All right. So let's take a look at 2. Let's take a look at 2. So what's the first thing that I do to deal with 2? What is the first thing that I do for 2? Trevor?
Put on the checklist.
Let's, okay.
Factoring out the greatest common monomial.
Okay, so is there a monomial that goes into all 3 of these terms?
No.
No, it doesn't. So therefore, what do I look for next?
Difference of
Go for it.
difference of squares.
A difference of squares. Is this a difference of squares? Okay, I see lots of people shaking their head. Why is this not a difference of squares? Why does what conditions does it not satisfy? Betsy?
It's not all of it is subtraction.
Not all of it's subtraction. That would discount it already. Trevor?
The last yes is negative,
Yep.
so it can't be this.
It can't be a square. Okay, so this is definitely not a difference of squares, nor can it be a square binomial because of this thing right here. So we are on to either doing the table or the rectangle. Since we did the table first time, let's do the rectangles this time. So we draw our rectangles, or rectangle. You divide it into 4 unequal sections. What areas do I know for certain? What areas do I know for certain? Allie?
On the bottom left, it would be a square, and then on the top right, it would have to be negative 15 squared.
Okay. So now we need to figure out our side length. So what is the distance from here to here?
A.
It's A. Obviously, that's also going to be A. What are some possible side lengths that would work for this side length and this side length? Good morning, Bergen. Trevor?
Negative 3b and negative 6. No, and positive 6b.
Okay, so let's try this. 6b times a is
6AB.
6ab. Negative 3b times a is
Negative 3AB.
6ab plus negative 3ab is,
Positive 3.
I'll just write it out. 6 minus 3 is 3, so 3ab. Does this match the middle term, the linear term? It does. It does match the linear term. So therefore, our equivalent expression of this equation is going to be what? Ethan?
A plus 6B, A minus 3B.
A plus 6b times a minus 3b. Okay. Are there any questions so far? You look riveted. Math gets you going.
It's really fun.
It's all right. So this time I want you on your own to factor this problem right here. Go ahead and factor this problem. Kyle and Landon, if you're watching, I want you to factor this before this class gets it done. Try to beat them. Let's go. When you have the answer and the word, please stand up. And put one finger on each hand up.
Wait, what? How do you do that? Put one finger. I don't know how this works. What the? Should I wait or?
Okay, have a seat. Have a seat. Ethan, take it away.
Oh.
There you go.
So what I did for this problem was a factor and sum table. And we want to factor out 33, negative 33. And our sum would be negative 32. And so what we did was we found factors of negative 33. And so we had negative 3 and 11. Negative 11 and 3. And then finally negative 33 and 1. And so negative 3 plus 11 is 8. And that's not negative 32, so that won't work. And then negative 11 plus 3 is negative 8, so that won't work. And then negative 32 plus 1 is negative 32, and that works. And so how you would rewrite this by saying P minus 33 times P plus 1.
Are there any questions? What did you do?
Plus 33 and
That would end up, if you did P plus 33 and P minus 1, if you try this, p plus 33, p minus 1, 33 times p is 33p. Negative 1 times p is negative 1p. 33p minus 1p is 32. But we are looking for negative 32. And so that's why it doesn't work. Okay? And that's why this gets a little trickier when the c value is negative. That's just the way it goes. All right, are there any questions on this material so far? Okay. It seems as though everyone is doing well with this, which is excellent.